So this is Jan 2023, Unit 4. We'll discuss the MCQs. The table shows a charge of up quark and a down quark. Which row in the table quark structure of a proton? So what is a proton? Proton is up, up and down. And what about neutron? It is down, up, down, down. And how we identify that? Because if you add up 2 by 3, 2 by 3 and minus 1 by 3, you will get plus 1. And for a neutron, it is a neutral. So up is 2 by 3 and down is minus 1 by 3 and minus 1 by 3 another. So they cancel out. So overall, it will become neutral particle. That's why for this one, C should be the right answer. You can identify from the quark composition. Otherwise, you just remember that it's a composition of a neutron. A lab centrifuge rotates at a 1500 revolution per minute. So 1500 revolution, how many radians? So 1500 multiplied by 2 pi. Because one revolution is 2 pi radian. So, and it is per minute. So it means it should be divided by 60. So 60 into 2 pi, 1500 into 2 pi divided by 60. So it matches with option D. A nucleus of an element emits alpha particle to produce a nucleus Y. Which of the following is a correct nucleon structure? So nucleus of an element X emit out and it turn into this Y, which is 233 and 91. And it is emitting out alpha, which is 4 and 2. So this should be 237 and this should be 93. 91 plus 2, then 93. So what is a proton number? How many are the protons are there? It should have 93 protons. And when we subtract 237 minus 93, so that will be 144. So B will be the right answer. Because we want the structure of X, the element which emit out this alpha. The diagram shows a track of a charged particle in a magnetic field. First thing, you have to identify where it is moving. Is it moving from X to Y or Y to X? Magnetic field is into. So it is moving from Y to X. Why it is moving from Y to X? How I identify? Because when the charged particle is moving in a magnetic field, it loses its energy. So when it loses its energy, so the radius of the track will decrease. Like if I draw a track like this, so where the particle is moving, A to B or B to A? So answer is A to B because the radius is decreasing. So we identify, first thing we identify the particle is moving from Y to X. Okay. Then what about the direction? It is a charged particle. Let's say it was a positive particle. So you will use your left hand. You will use your left hand. For your index finger represent the magnetic field. According to a question, it is into. Your second finger represent the direction of the particle. It is moving from Y. So I can draw here. So according to this, if my index finger is pointing into, my second finger is pointing in the direction of the particle at position Y. Where my thumb is pointing downward. Means if it was a positive particle, it should go like this. But it means this is not a positive particle. It means it is a negative particle. So negative particle move in opposite direction. Is it clear? So I apply the rule and I found it is not following the rule. That's why it is in opposite direction. In all cases, the radius decrease because, in all cases, the radius will decrease because it is losing the energy. That's right. Which of the following statement is not valid conclusion for the alpha particle experiment? So a similar question is there as we discussed in the last paper. Most atom is empty. Most of the mass of atom is concentrated in the nucleus. Nucleus contain all the charge of an atom. That is not the valid conclusion. Nucleus is charged, that is a conclusion, but nucleus contain all the charges of an atom. It's wrong. Why? Because around the nucleus also there are electrons which also carry the charge. So this is not the valid conclusion. The radius of a nucleus is very small compared to radius of an atom. That's right, like a size of a nucleus is negligible as compared to size of an atom. From this experiment, we did not get conclusion for electron or yeah, from this experiment, there was no conclusion about electron or proton. That's right. The question is, which of the following pattern is an electric field for positive and negative charge? So negative it will point into and positive it will point out. So B will be the right answer. It's just a pat from positive to negative. Question 7. Which of the following statement is true for a cyclotron? So cyclotron, what is the purpose of these are particle accelerators. So what is the purpose of the cyclotron? It is used to accelerate neutron. No, cyclotron it can only accelerate the charged particle, not the neutral particle. Cyclotron uses a magnetic field to increase the speed. No, the cyclotron is not using magnetic field. It uses magnetic field to deflect and electric field to accelerate. The cyclotron use alternating potential at a constant frequency. That's right. In a cyclotron, if you remember, there is a constant frequency is applied. Like every second, the terminal will change. So first it move. Say this is positive, negative, then it will deflect. Then this will be positive, negative, accelerate, then deflect. Then accelerate, deflect, accelerate, deflect, accelerate, deflect. Yeah, linear particle accelerator also uses a constant frequency. Both uses a constant frequency potential. Like constant frequency means like same time every second it will like in a same time interval the terminals will change. These are not made up of a magnet. These are made up of a magnetic material like iron. A cyclotron uses electric field to keep the particle moving in a circular path. No, it uses the magnetic field so that the particle continue to move in a circular path. Where the magnetic field is coming from, we have external magnets like we have this is a D, these are the D, and we have the external magnets are there. This is a D. This part is looking from the top, and here it's a side view. A non-relativistic particle, when we say non-relativistic particle, it means its mass is not changing. Like if it moves close to speed of a light, the particle changes the mass. We call relativistic effect. And when particle move close to speed of a light, the mass will increase, the length will decrease, the time will also decrease, which is called time dilation. A non-relativistic particle of a mass m, momentum p, and kinetic energy a second particle of a mass m by 2 and momentum 2p. We have the formula Ek is equals to p square over 2m. So what is the relation between which of the following expression give the kinetic energy of the second particle? So for a second particle, the mass is half. According to this formula, the relation between kinetic energy and mass is inverse. So if the mass is half, what will happen to kinetic energy? It increases by 2. And the relation between kinetic energy and momentum is proportional square. Means if the momentum is 2m, like momentum is double, what will happen to kinetic energy? It will vary with the increase with the square, increase by 4. So what is the total change in a kinetic energy? Because of this, it will increase by 2, and because of this, it increases by 4. So the total increase in the kinetic energy is by 8. Is it clear? A ball traveling at a speed u collides with a wall at a right angle and bounce off with a velocity v in opposite direction. The time for the collision is t. Which of the following expression gives an average force on the wall during a collision? So in this case, one of the velocity we have to take as positive, the other one will be negative because the direction has changed. So if I take initial as negative, the final will be positive, and or other way around, I can also take the other way around. So if we need the which of the following is the force? Force is a change in rate, impulse over time, or change in momentum over time. So what is the final momentum? It is mv minus, what is the initial momentum? It is minus mu. When I simplify this, this is minus mu. So minus minus plus, so it will be mv plus mu over t. So mv plus mu over t, or it matches with option A. Let's say student takes the other way around. Like example, another student took initial velocity as positive. So in that case, the final velocity will be negative. And if I want the impulse, which is minus mv minus mu over t. If I take minus common, negative common, so it will be mv plus mu over t. So we get the same result, mv over mv over t, and the negative sign only shows that it is in opposite direction. But we get the impulse by adding the two momentum. When the direction changes, become exactly opposite, and you need an impulse, you will take the impulse by taking the summation of the two. And it is divided by the time interval, not 2t. That's why these two are totally wrong. So we compare, this is a subtraction. So here we have to add the two. A proton is accelerated by a uniform electric field after time t. The speed of a proton increased by delta v. The helium nuclei is accelerated by the same electric field. After the time, will the helium nucleus achieve the same change in after what time it will achieve the same change in speed? So we want, according to a question, like the same change in speed we want. If you compare, first it was a proton, and then what we have, first we were having a proton is there, and then we have a helium. Helium, what is the mass of a helium? Helium is 4 times. We want them to have a same change in speed. So if I write the time, no. I will solve this. Look, acceleration is what we want, the same change in speed, and we want the same electric field is there. So electric field is given by a formula. So the two particles in the same electric field. So electric field for a proton, like what experienced by a proton, so same electric field is experienced by the helium. Then what about the electric field? E is equals to F over Q. Just a minute. So E is equals to F over Q. So we have the formula F E is equals to F over Q. I was solving here, and F is equals to MA. So I can write MA over Q. And what about the acceleration? Acceleration is the change in the velocity, like delta V over T. Acceleration is the change in velocity, so it is delta V over T. Now, if I substitute, like the mass of a proton is MP, mass of a proton is M, acceleration of a proton is A, which is delta V. In place of acceleration, I can substitute delta V over the time for the proton, and Q is the charge. What about here? The mass of a helium. The mass of a helium is 4m because the nucleon number is 4. So mass of helium is 4. Delta V, the change in velocity is same. And what about the charge? Q is the charge. So what is the charge? Its charge is plus. So the charge is 2q over T. This time is called T1. Like example, this time we call T, and this is the T1 and T2. Now we simplify. M will cancel with M. Delta V, they have the same change in velocity, will cancel out. Q will cancel with Q. And this will be 2 and this will be 1. So if we simplify, so the T2, the second time is twice of the first time. So the new time will be twice of the first time. So B will be the right answer. So not only because it has a different mass as well as it was having a different charge. If mass was only the difference, then yes, it will be like 4 times. But because the charge is different as well and the mass is different, that's why when we simplify, we got that as twice. Is it clear? Okay. So this was January 2023 paper, Unit 4 MCQs.